Hi guys, welcome back to another Mr. Hutton science video. Thanks to all the subscribers out there, especially those guys down at St Clement Danes School. Keep the subscriptions coming in. We've hit 150. Let's push on through to 200. Okay, today's video, reacting masses. This goes alongside the AQA GCSE chemistry course, but like always it would be suitable for any other specification out there you might be studying. Just before we start, let's make sure we've got mobile phones turned off, we've been to the toilets, got yourself a drink and a pen and paper, something to write with to make some notes. Right, let's get going. So what you know already, or what you need to know, okay? There's several things you need to know when we're looking at reacting masses. You need to be able to determine the AR or MR, so AR of elements or MR of compounds, so you need to be able to use the mass numbers from the periodic table to find out the AR of elements and the mass numbers from the periodic table to find out the MR of compounds. If you're unsure about those two phrases, then go back and look at the video on moles and that should clear things up for you. You need to know how to calculate moles when you're given the AR or MR. So again, if you're unsure about moles, check out the other video that I've done previously. You need to be able to know how to write and balance an equation. So that's really important, because if you cannot balance the equation, then that is going to end up with you getting the wrong answer later on in the question. So if you're unsure how to balance equations, then again I've done a video on that, so you can check that one out. Remember the law of conservation of mass. Okay, the mass of your reactants must equal the mass of your products. If it doesn't, then it's likely that you've gone wrong somewhere. And most importantly, really, know how to use your calculator. There's several different calculators out there. Make sure that you know how to use your one. Regularly, students will get the wrong answer because they've input something into their calculator incorrectly or just misread it. So answering questions on reacting masses, we're going to follow a process. It's a 7-step process. Okay. And step 1 involves you writing out an equation if it hasn't been provided. It's likely with a lot of questions the equation will be provided, but you have to be prepared to be able to write one from the description given. Even if you've got an equation, you need to do step 2, so make sure the equation is balanced. Okay, so again, check out the video on balancing equations if you haven't already. Step 3 is quite straightforward. We're just going to write down mass, MR and moles down the left hand side of our page. Okay. Step 4, we then add any information we can find from the question. Okay, this will usually be mass and MR of one of the species. Step 5, we calculate the moles of one of the species. Like I said in step 4, it's likely you should have the mass and MR of one of the species, which means you can then calculate the moles of that species. Step 6, we need to use the molar ratio of our balanced equation to determine the number of moles of another species. And then step 7 is calculate the mass of the species once we've calculated the moles using our molar ratio. So the best way to try and get this is purely just do some questions, run through it step by step, and you should get the correct answer. We're going to go through some 1 to 4 questions now, just to give you the idea of how to do things. Question 1. Ethanol can be used as a fuel. It burns in oxygen to produce carbon dioxide and water. A petrol tank can hold 50 kilograms of ethanol fuel. How much oxygen in kilograms is needed to react completely with this amount of fuel? So here the equation hasn't been given for you, okay, but you do have the formula for ethanol there in case you didn't know. It will burn in oxygen, so we're going to react it with oxygen to produce carbon dioxide and water. So we write the equation first of all in step 1. So secondly, step 2, we need to make sure the equation is balanced. Okay, so there you go, we've now got C2H5OH plus 3O2 reacts to give us 2 CO2 and 3 H2O. Okay, so step 3, straightforward, we're just going to write down mass, MR, moles down the left hand side. And then step 4, we need to add in any information we've got from the question. Okay, so in the question there, it tells us we've got 50 kilograms of ethanol, and we've used our periodic table to calculate the MR of ethanol, the MR of our oxygen there, carbon dioxide and water. We're only really interested in ethanol and oxygen in this one, but we have just added in the carbon dioxide and water just as an example. So step 5, we've got to calculate the moles of one of the species. As you can see, for ethanol we've got the mass and the MR, so we can do 50 divided by 46 to give us 1.09 moles. Now the question is asking us how much oxygen is needed, so we have to look at the molar ratio between ethanol and oxygen, and it's 1 to 3, and we can use that to then divide our ethanol by 3. Sorry, we've got to times our ethanol by 3 there because we've got a 1 to 3 ratio. So it's 3.27 moles of oxygen. So step 6 we've just done, and we're going to look at step 7 now, where we calculate the mass of the other species in the question, which in this case is oxygen, and we need to multiply 3.27 by 32 to give us 104.64 kilograms. Okay, there's a bit of confusion there on my part, so if you're a bit unsure, then just go back and go through that video once more. We have got another video, another question, coming up, question 2. I haven't got the colours in this one, but hopefully I'll talk you through it anyway, and you'll get the idea. So question 2, a student carried out an experiment to make aspirin. The equation for the reaction is below. Calculate the maximum mass of aspirin that could be made from 2 grams of salicylic acid. So this time, step 1 has been done for us. We've got the equation already written out. Double check that it's balanced. It's for step 2, okay, and then as far as I'm aware, it's balanced. And so we're now with step 3, writing down mass, MR and moles, and then that takes us on to step 4, adding in other information from the question. So we've added in there, we've added 2 grams for the salicylic acid, and then you can see we've calculated the MR of our salicylic acid and aspirin. If you're unsure how we got those numbers, in the grey below is a description of how we've used the relative atomic masses from the periodic table to calculate the MR of each of those species. So now we're on to step 5, where we can calculate the moles of one of our species. So we can calculate the moles of the salicylic acid. So we've done 2 divided by 138 to give us 0.014. Now then, step 6 is a 1-to-1 ratio, so it will be the same number of moles of aspirin. Okay, and then step 7, we're going to multiply the moles of aspirin by our MR of aspirin to give us our mass of aspirin, 2.61 grams. Again, if you want to rewind the video or pause it just to catch up with any notes, then do that. Otherwise, continue to question 3. Silicon is an important element used in the electronics industry. Silicon can be made by heating a mixture of sand, which is silicon dioxide, with magnesium powder. Calculate the mass of silicon dioxide needed to make 1 gram of silicon. Right, so again we've been provided with an equation here, so step 1 is done for us. They've balanced it as well, so step 2 has been done for us. So we're straight into step 3, where we write the mass, MR and moles. So straight on to step 4, add any information from the question. So we know we've got 1 gram of silicon, and we can use the periodic table to calculate our AR and MR of silicon and silicon dioxide. So now we can calculate the moles of silicon, all right, for our step 5, which is 0.0357. It's a 1-to-1 ratio again, so we'll have the same for silicon dioxide, so 0.0357 again. And now for step 7, we can calculate up, so we're going to times our moles by our MR to give us our mass of 2.14 grams. If you need to pause the video or go through that question again, please do so now or carry on to question 4. Question 4. Fluorine reacts with sulfur to produce sulfur hexafluoride, SF6. Calculate the mass of sulfur hexafluoride produced when 0.950 grams of fluorine is reacted with an excess of sulfur. Give your answer to 3 significant figures. So here we've got a question. We don't have an equation, so we're going to need to write an equation initially. Okay, so step 1 is writing out that equation. So we've got sulfur plus fluorine. Remember, fluorine is diatomic, so we've got F2, and it reacts to form sulfur hexafluoride. Okay, if you're unsure of the formula, it's given in the question. And as you can see now, we've got 2 fluorines on the left of our reaction and 6 on the right of our reaction. So we need to balance this equation up. So we put our 3 there. So now we have 6 fluorines on the left and 6 on the right. So step 3, very straightforward. We're going to write mass, MR, moles. Okay, so step 4 is adding information from the question. So the question tells us our mass of fluorine. We can work out our MR of fluorine and of sulfur hexafluoride from the periodic table. And now that we've got 2 things, we've got the mass and MR of fluorine, so we can calculate the moles of fluorine. So for step 6 now, using the molar ratio, we've got to look, we've got a 3-to-1 ratio. So we've currently got 3 times as many moles for our fluorine, so we need to divide by 3 to get the sulfur hexafluoride. And now we've got the moles and the MR of sulfur hexafluoride, we can do step 7, which is calculate the mass of the species by multiplying moles by MR. 1.22 grams. Right, so on the next slide you're going to have a go at this. If you need to just run through these examples again, do so now. Otherwise, continue to the questions. Here you go, guys. There's 3 questions here for you to have a go at. Follow it through. If you're unsure, then go back and look through the video again at the examples. Or you can continue on and reveal the answers. If you pause the video now, have a go at those questions and then continue to the answers. Alright, there are the answers there. Hopefully you've got those correct. If not, just go back and double check a few of your calculations. You may be slightly out with the decimal places and decimal numbers just because you may have used a different number of significant figures in your calculations. But you should roughly be the same. If you're a long way out, then certainly you need to just double check what you've done with your calculation. Go and see your teachers at school or drop me a note at the bottom and I'll see if I can help out. So that's another Mr. Hutton Science video. Please look out for the next one. Make sure you subscribe and get those notifications, and I'll be back soon with another video.